Now if you see the this is based on the given information, we'll form two equations and we have to find the third equation which will make the other two linearly independent or linearly dependent. So we will multiply this with x, we will multiply this with y, we will add them. Now this is the equation that we get, and this is the um, now what we'll do is we'll equate this to the coefficient here and we will equate this to the corresponding coefficient here and we'll get the x and y. If we substitute x and y, we have to get the other coefficient 5. This is how we will check the linearity. Minimizing and maximizing. If it is given the numbers are integers, take the possibility of negative integers into consideration. Then you can work accordingly. See, in this kind of a question, you have to infer certain things, and through repetition this logic will be embedded into your mind. If you see here, a plus, this is the, you read the question and it is given this is the ratio. This should imply that the entire sum should be a multiple of 9, and this should imply that the entire sum is multiple of 2 also, and this is a possible value of the summation, and accordingly we will draw out different possibilities, then we'll proceed further. Now if you see this, a cube b square is like this and we have to find the minimum of this. What we can do is we can divide it by 3 times, and we can divide it by 2 times, and this should be greater than or equal to fifth root of this cube on this square, right? And that's how it is. Okay, we divide it by 3 because we'll have the power 3. It gets multiplied thrice and we'll get 3 in power. This is quite a lengthy problem, but the logic is useful. This is a given equation. We introduce a term k in such a way that we'll get this reduced. Why 2 is used? That's the question. Why 2k minus 1 is used? Because we'll reduce the n value as well as we'll divide it by 2. That's the only purpose you identify this problem. Now we'll get an equation. We'll simplify the given equation. We'll get another form of equation. It's up to you. Either you can do the same with this equation as well, but this will reduce the time required. Now we will substitute different values for k, and we'll take out of these 3 variables, we'll take the variable with highest coefficient. We'll substitute different values and we'll find the number of positive integral solutions accordingly. This is a good question. In this, if you see, we have to find the value of t, smallest possible value of t. It can be expressed as product of 2 quadratic expressions. This is a hint. Now I try to find 4 roots and then solve from there, but this is a simple and quick approach. You can write this in the form of 2 quadratic equations, and equate the corresponding terms and you find the values of coefficients. Now you just jot the different possibilities and you can arrive at the required result.